All right, welcome everyone. Welcome to Best Practices for CI/CD using Fargate and ECS. I'm Claire Liguori. I'm a principal engineer for AWS Containers. And later on, we'll hear from Singwei Su, also from the AWS Containers team. I'm really excited to be talking about this topic this year because I think CI/CD is especially important for containerized applications. So often when we see customers moving to containers from more traditional server-based architectures, they really have to rethink their applications. Previously, they've put some complex applications, kind of packed them all onto the same server. But when we look at a Docker file, it really requires us to think critically about what is the single responsibility for this process? What is the single responsibility for this container image? We only get one command that we can run in the container. And so often when we adopt containers, we start to adopt more modern architectures. We're typically adopting microservices architectures. And so we now have this explosion of things that all do one thing really well, but we now have also an explosion of things we have to deploy. So now we're spending all this time deploying to all of these microservices instead of writing code for those microservices. And so I think CI/CD is so important when we start to adopt containers and these microservices architectures. So today what I want to talk about is 3 best practices for CI/CD, automated releases, safe deployments, and repeatable infrastructure changes. So let's start with automated releases. At Amazon, we counted up all the deployments we do recently, and in the previous 12 months when we counted, we had done 190 million deployments. This is kind of a mind-boggling number. This is more than 6 deployments per second. We don't have 190 million engineers at Amazon, so we've had to automate these deployments. We've had to embrace CI/CD and automated releases in a big way in order to achieve this velocity. So what I want to do is show you what a pipeline looks like inside of Amazon so that we can achieve these 190 million deployments. So of course, a CI/CD release process starts with our source, but it doesn't just start with our application code. We also have infrastructure as code. If we're using containers, we have a base image for our code, and then we have configuration. All of these things can trigger the pipeline and start that automated release. So then that triggers the build, and of course, out of the build comes an artifact, and in the case of containers, that is our container image. And then we have not 1, not 2, but 3 pre-production environments for our microservice. So we go through these sort of different levels of rigor in our testing of each of these stages. Alpha is almost always broken, but that's our first stage where we're running automated tests against our deployed container image. And then we start to run integration tests with other systems. In beta, we might run integration tests against another service's beta stack, or we might run integration tests against another service's production stack to ensure compatibility. And then we start running load tests automatically kicked off by the pipeline, browser and UI testing, more integration tests when we get to Gamma. We run canaries or synthetic traffic against Gamma all the time and make sure that those are healthy when we deploy new code to that stage. And then finally, smoke tests and fuzz testing against that code. And then finally, we're ready to go to production. But we don't deploy to all 20+ regions at the same time. We start really small. For so many cases, we catch the problems in pre-production in one of our stages. But of course, it happens that not all code paths that customers have hit are actually tested in pre-prod. Sometimes customers will end up hitting a code path or a specific sequence of paths that cause problems. And so we deploy really small first. We'll pick maybe 1% or 10% of one region to deploy to, or we'll pick a particular zone to deploy to really limit the blast of any changes getting into production that are causing problems. And then we'll roll out to the rest of that region, maybe to the other zones or the rest of the fleet in that region. And then we'll go to another region, and then 2 more regions, and then 3 more regions, and so on, to really control the rollout of the change going out to production and constantly monitoring that change for any problems that customers are hitting. And then on top of all of this, we have a lot of configuration of the pipeline, code coverage, making sure that code has hit a particular percentage of unit test coverage, code review, ensuring that every change that goes out to production has been peer reviewed. We do security scans, we ensure dependencies are up to date, we do time windows, meaning there are certain times like the weekends that we don't deploy. For example, during reInvent, we don't deploy typically. And then we have policy configuration to enforce this across all of the pipelines for a particular business unit. So this is a lot of complexity. This has been built up over many, many years of us embracing automated releases. And so I want to simplify today for folks who are just starting their CI/CD journey. I think that we can start small and get some benefits from automated releases and then build up on that. So today I'm going to start with 4 basic release process stages for CI/CD: source, build, test, and production. So source stage, we're checking in our source code files. That triggers the pipeline. In the build, we're creating our container image. Then we deploy that image to a test environment. We do integration tests with other systems, load testing, UI testing, security testing. And finally, we deploy into 1 or more production environments, getting that code in the hands of customers, and then monitoring that in production so that we can resolve any issues really quickly. So how do we implement this release process? How do we get started deploying automatically to an ECS or Fargate service? So on the ECS team, we've been working with a number of tools, integrations with a number of tools, so that you have choice in what you pick for your CI/CD process. I think that having an automated release is more important than which tool that you pick. So I'm going to cover all of these and what it looks like to actually implement a pipeline in these tools. So for most of the examples today, I'm going to use CodePipeline. CodePipeline helps you model and visualize your release process in a pipeline visualization. It builds, tests, and deploys your code every time code changes, and it integrates with both third-party tools and AWS services like ECS. So in order to implement the release process on top of CodePipeline, let's first start with source. There's a couple of options for triggering the pipeline based on changes. So source can mean different things. One, it can mean a branch in a Git repository from code commit or from GitHub. You can also pick an object or a folder in an S3 bucket, and CodePipeline will monitor that for changes. So that might be configuration files, for example, that you store in an S3 bucket. Or you can pick a Docker tag. So for example, your base image that you want to pull from and automatically release changes to that base image to your pipeline, you can pick that from an ECR repository. So now what we've built, what do we use for build? We need to create that container image, and I typically use CodeBuild for that. So this is a fully managed software build service. It scales continuously, so there's no build queues to wait on when things get pretty active during the day. And there's no build servers to manage. So CodeBuild does that all for you. It's a fully managed service. And then you pay by the minute. So what I like about CodeBuild is that it's really great for containers specifically. It helps you to build, push, and validate your Docker images. The Docker CLI and the AWS CLI are built into every official CodeBuild environment. So it's really easy to use for containerized services. IAM role credentials are populated into the build environment automatically, so you can log into ECR and push your images there. And then you can even, because we're all fans of containers, you can even create a custom build environment Docker image. So if you have a specific mix of tools that you like to use, install different CLIs and things like that, you can do that inside of a Docker image and provide that to CodeBuild. So in order to tell CodeBuild what you want it to run, you create what's called a build spec file in your source code repository. And these should look pretty familiar. These are familiar commands to all of us. These are probably what you're running on your laptop all the time using Docker. So Docker build, tag, and push. And what I like about the build spec is that it's really easy to figure out what is it that the build is going to do. These are familiar commands that you do every day to build your code locally. One of the things I want to call out is I have a little placeholder there for image tag. I want to call out some best practices for image tagging as part of the build. So typically we start with tagging things as latest. This is the default. It's the easiest thing to do when you get started with containers. But this can actually cause some issues in production. So here I have an ECR repository with an image tagged as latest, and I've deployed that image latest tag to a Fargate service. So that's fine, it deployed fine, all of my tasks came up. Now what happens when I have a new build in my pipeline and I re-tag as latest? So now I have a new digest, a new SHA-256. This is a brand new image tagged as latest. Now my Fargate service scales out. I now have that new latest image that I just built and I just pushed. I may not have even deployed it into my test environment yet, and already it's being spun up in my production environment because I had a scale out event, and that latest tag is resolved to the digest every time a new task launches. So I highly encourage using immutable tags, something unique every time you build. So an example of that is simply using the CodeBuild build ID, which is a UUID, to tag the image, and that makes it really nice to be able to, one, know exactly the image that's being deployed to production, that never changes, and two, be able to know what build produced this image. And you can look at the build and you can see what source code was involved in building that image and what build spec was used to build that image. But I like to have a couple of levels of security here, and so I also recommend using ECR immutable image tags. This is a recently released feature for ECR, and what it is that it prevents you from inadvertently overwriting any of your tags. So you can set this as a configuration on your ECR repository. You set the image tag mutability to immutable. And then anytime you try to overwrite a tag, latest or a commit SHA or anything like that, it will return an error to your Docker client, and that will fail the build. So it'll tell you there's already an image with this tag, you need to generate a new one. So that's just a nice safety check in your pipeline to make sure that your build fails if you're accidentally overwriting a tag. So we've seen Docker build, Docker tag, Docker push. What do we do to validate this image before we move on in the pipeline? Often we'll do some tests, run some unit tests in the image, maybe mock some local dependencies and run our integration tests with the image before moving on. But the other thing that we can do is security scanning. So ECR recently released image scanning, image vulnerability scanning for ECR repositories. So this is a new feature where you can configure your ECR repository to automatically scan your image for known vulnerabilities. It'll look for what are the different libraries you have installed in your Docker image, and are there any open CVEs for those libraries. So as soon as I push as part of my build, then I can turn around and describe image scan findings, and that will return all of the vulnerabilities ECR has found, as well as the severity of those CVEs. So you can, for example, in your build script say, I want to check that there's no high severity vulnerabilities, CVEs found against my image by ECR, and fail the build at that point, preventing that image from getting deployed down the pipeline. So then we have our build image, it's been scanned, we've run some tests against it. Now we need to deploy into test and production. And CodePipeline supports direct integration with ECS, so it can deploy that new updated image to your ECS service. So overall, the pipeline looks like this. We have our source code, we have a master branch with our Docker file in it. We use CodeBuild to build the image. We deploy that image using the ECS action in CodePipeline to deploy to our test and production environment. One of the things I think is important, though, when we talk about CI/CD is that this is sort of a very personal, very custom process. Your automated release process needs to fit the needs of your organization. So it needs to be very flexible. So for example, very often we see different customers have some kind of a central IT team or a central DevOps team that owns specific images. They build the images and they distribute them to the application teams. So for example, the official base image that you use internally, like the official Java image or official Ubuntu image. Or you might own the official sidecar image, like an official logging container or official Envoy container. And so that team needs CI/CD as well. They're not deploying out to production directly, but they need CI/CD so that they can go off and do more important things than building images by hand. So CodePipeline is flexible enough to also model different types of release processes. So for example, here I don't have any test or production stages. I just need to build an image automatically and push that to some kind of release tag that other teams can pick up on and start their pipelines. And so if I'm an application team and I have a pipeline similar to one we looked at earlier, where I'm deploying out to ECS, then I can add that ECR central image repository as a source of my pipeline. And I don't have to go and check on a regular basis whether that new golden image for base or sidecar has been updated. I can simply let my pipeline trigger and go write some more code. And then for the sidecar image, that can be deployed into my ECS service directly as a sidecar. It doesn't need to be rebuilt in my build stage. So I think it's important to design your pipelines to meet your own delivery needs. I think it's important to customize what your pipeline looks like to meet your needs and the responsibilities of different groups in your organization. But it's also important to pick the right tool for you to use. And so we've been working on some different integrations with different tools. So recently we released 4 GitHub Actions as part of the GitHub Actions general availability launch last month. So we released 4 actions. I'm showing 2 of them here. One is configure AWS credentials, so you can store your AWS credentials in a GitHub Actions secret. And then this will configure the GitHub Actions environment for that. And then deploy task definition action, which will take a task definition JSON file in your source code repository, in your GitHub repository, and register that and deploy that to your ECS service. So then you can also use Jenkins. I think that the AWS CLI works the best in Jenkins for automation in Jenkins. So you can do register task definition, update service, and then I think the ECS wait services stable command is really great for being able to make sure that before your pipeline moves on, that all of your tasks actually came up when you updated the service with the new image, and that the service is looking stable. And then finally, Spinnaker. We've been doing a lot of work with the open source project Spinnaker this year. Our focus this year has been on making sure that you can deploy any of the ECS attributes with Spinnaker that are available in ECS. And so this year we reached the milestone of being able to deploy any task definition attribute with Spinnaker to ECS. So you can check out the ECS Cloud Provider, or Spinnaker, what they call for plugin, in Spinnaker this year. So we've talked about automated releases and how important it is to automate the release and make the release process fit your delivery needs and the needs of your organization. Let's now talk about safe deployments. So at Amazon, we do a lot of deployments, as I said before, 190 million. And so because so many of these are automated, we need to have a certain bar for deployment safety. So many of them don't see a human touching them after the human has pushed into the source code repository. It's completely hands-off. And so we need the system to take care of it for us. So our first tenet for deployment safety is rollback automatically on alarms and validation tests. What we found across all of the services that we operate, people are just too slow. They're too slow to page when there's problems going on. They're too slow to figure out which pipeline they need to roll back. They're too slow to figure out how to roll it back in the tool. And so number one tenet that we have here is to roll back automatically so that it happens automatically if any alarms trigger or if any validation tests fail. The second is to roll back quickly. So if the deployment or the rollback take hours to complete, then that means that we're going to continue to have issues in production through that whole long rollback. So it's important that we design the system to have very fast rollbacks. Third is to bake after deployment. So what we've found doing all of these deployments is that customers don't always hit all the code paths and trigger all of the alarms before the deployment is finished, before we've actually spun up all of those ECS tasks, for example. And so it's important for us to wait a little bit, to let it bake in production before we declare success on the deployment. And so we'll wait for as little as 30 minutes or an hour or up to 24 hours before moving on to the next production environment and the next deployment. So this helps us to continue to monitor those alarms and make sure that customers aren't hitting any bad code paths or having any problems, any latency regressions. And if at any point during that bake time we see those problems, the system automatically rolls back. And the fourth is to deploy small at first and then more broadly. So I showed you that Amazon pipeline before and how we pick a small percentage or a single zone to limit the initial impact of new code getting into production. So in order to implement this in your own CI/CD pipelines, I recommend using AWS CodeDeploy. CodeDeploy automates code deployments to instances, ECS services, and Lambda functions, so you can really use it across many of your applications. And you can use CodeDeploy to really avoid downtime. So it makes sure that it's launching the new services or new tasks before tearing down the old, and it will roll back automatically if failure is detected. You can limit customer impact with traffic control, which I'll explain what that looks like in ECS. But CodeDeploy really meets the deployment safety bar for Amazon, so we tend to use this internally for our services in AWS as well. So last year at re:Invent, we announced CodeDeploy ECS blue-green deployment. So I want to show you what that looks like and how to use it to implement deployment safety. So if you run an ECS service that's behind a load balancer today, this should look fairly familiar. So you have an application load balancer, you have a production traffic listener, hopefully you're using HTTPS, so you have port 443, and that traffic is going to some target group, and that's going to the tasks the tasks in your ECS service are registered into that target group. So this is going to form our blue set here. We have a blue target group that all the traffic is going to, and we have a blue task set. So if you're not familiar with task sets, that was an API that was released earlier this year. Task sets are basically subgroupings within a service, within an ECS service, that gets to have their own task definitions. So you can have one or more task sets that each have their own task definition. And you can have different target groups for them. And so in order to get set up for blue-green deployments, you then have to have a green target group. So you'll also have you have a blue and a green target group that you can flip traffic between, and you'll have a test traffic listener. So this is really nice for being able to have sort of that last chance validation before production traffic hits the new tasks, the green tasks that are going to start up. And really why this is important is because so often we see those slight changes between the test and production environment. And so it's really nice to be able to do integration tests against your code in production before production traffic actually hits it. So when the deployment starts, CodeDeploy will create a new task set inside of the service. That will have 100%, what's called 100% scale. So if the desired count for the service is 3, we have 3 blue tasks and we have 3 green tasks. So at this point, no traffic is going to the green tasks, so we're just waiting for them to come up and become stable. And then CodeDeploy is going to shift that test traffic on that port 9000 over to those green tasks. So at this point, production has not been affected at all. If this is a totally bad change, customers never see this change. But we have the opportunity, with our CodeDeploy configuration, to run integration tests against those green tasks on that port 9000. So the way that you do that is you create a CodeDeploy app spec file, and you provide this to CodeDeploy. CodeDeploy has a set of lifecycle hooks. So before install, after install, where we are in the deployment now, it's shifted test traffic to that green test set. And so we are in after allow test traffic. And these are just Lambda functions that you can write in order to hit the test endpoint, in order to go check other things that you need to validate the deployment. And then this is a sample Lambda function for that test traffic hook. So here I'm doing a really simple change. I just request the API on port 9000 and then check that it's a 200 response. But you can do much more deep integration tests here to ensure that those containers are behaving as you would expect in the production environment. So now that we have the hook has run, it has successfully reported status, we can move on. If the hook reported failure, what happens now is that CodeDeploy will just spin down those green tasks, and production traffic has never been impacted by this. So if the hook is successful, the task will move on. CodeDeploy is going to shift production traffic to green. So at this point, we have production traffic moving to green, and we can have CodeDeploy configured to monitor alarms during this time. So if any of the alarms go off during this time, it's really easy and fast for CodeDeploy to roll back. We've not yet spun down those blue tasks, and so they're still waiting there idle, ready for traffic. And so CodeDeploy just has to make a load balancer API call to shift traffic back within seconds, back to that blue task set. So in order to do that, you create a CodeDeploy deployment group. This basically tells CodeDeploy what ECS services you want to deploy to, and you can also specify what CloudWatch alarms you want to deploy to. So if at any point any of these go into alarm, CodeDeploy is going to roll back and get you back to the last known good state. And then finally, I talked about bake time being so important at Amazon. You can also configure bake time in CodeDeploy. It's called termination wait time, and so for a blue-green deployment, what you don't want is for CodeDeploy to immediately start tearing down those blue tasks. Otherwise, rollback is not going to be fast. You're going to have to relaunch all of those blue tasks again. So I have here bake time set to an hour. During that time, those blue tasks are going to hang out there ready to take traffic. If at any point during this time the alarm goes off, CodeDeploy is just going to make that load balancer flip and get back to those blue tasks. So we've decided that this is good. The bake time has been successful. None of our alarms have gone off. And so now CodeDeploy is going to drain that blue task set out of the service. So in order to add deployment safety to your CI/CD automated releases, you can either use the CodeDeploy ECS deploy action in CodePipeline, or you can use the AWS ECS deploy command in the AWS CLI to add it to any automation that you're using today. So this command will register the task definition, start the CodeDeploy deployment, and wait for that deployment to complete successfully. So it's really nice to be able to add this to your scripting and fail your pipeline based on whether this command succeeds or fails, based on whether the CodeDeploy deployment succeeded or failed. So now we've talked about safe deployments in the Amazon deployment safety bar. Let's now talk about repeatable infrastructure changes. So often, when we talk about deployments and we talk about CI/CD, we're really talking about that application image, right? We're talking about building a new image, deploying that new image, but there's so much that happens around our application image in production that can impact our problems, our customers. So if we have this application image, we also have an ECS service around it that has its own configuration, like desired count. Then if we have a load balancer, we've got to set the traffic port, we've got to set the health check, we have to have a security group, we have to have a DNS entry, we've got all the load balancer configuration, the TLS certificate. And then of course we want our application to be observable, so we've got alarms and logs and metrics and dashboards. So there's so much configuration here that can impact our application in production. So it's so easy for me as a developer logging into the console, going to the load balancer console, creating these load balancers by hand in test and production. And it's so easy for me to just have the wrong health check there. And so this can have real impact to our production reliability. So if we deploy our new application image freshly built into test, we validate it with integration tests, this all looks good. Now we deploy it into production, and all of a sudden, traffic is going to containers that are unhealthy. But the health check is wrong. It's going to the wrong path. And so it's so easy for us to sort of lose confidence in our CI/CD pipeline because the infrastructure is impacting the behavior of our application image in production. And so I think infrastructure as code is so important for containerized applications in the cloud. So as an example of how to get myself out of this situation, I can use CloudFormation and an infrastructure as code template to specify that health check path for both test and production. And then I can use the same template in test and production to stamp out my load balancers and ensure that I can have confidence in my CI/CD process. So at Amazon, for our containerized applications, we've found that the best thing for us is to combine infrastructure as code and application image deployment into the same CI/CD pipeline. So what that looks like is that our repositories that are the source of the pipeline have both that application code and the CloudFormation template file. And in the build stage, what happens is that we build and push the container image as normal, but then we update the CloudFormation template file with that new image ID. So what gets promoted in the pipeline is actually that new CloudFormation template file. So we have here, we'll usually have like a placeholder or something like that in the source code repository for a template, and then the build will actually update to the latest digest that was just built. And so then in test and production, all we're doing is deploying out that CloudFormation template file in both test and production, and then running our integration tests and monitoring. And so this gives us pretty good visibility into what exactly is the state of the infrastructure in test and production, what commit ID was it deployed from, as well as what application code is currently deployed to test and production. So that doesn't really help us with all of this configuration. We still have to write down all of this configuration with infrastructure as code that can become quite long. I don't like to spend most of my days writing YAML. And so I highly recommend checking out the Cloud Development Kit, CDK, for authoring your infrastructure as code templates. So CDK is an open source framework that lets you define that cloud infrastructure in your favorite programming language. So it supports TypeScript and JavaScript, Python, Java, and .NET, so you can really pick your most familiar programming language. It still provisions all of the resources with CloudFormation, so you still get that nice managed provisioning experience with CloudFormation, and it automatically supports all of the CloudFormation resource types. So you only have to wait for the next release of the CDK when there's a new resource type in CloudFormation, and it'll automatically get built into the next release of CDK. But what I like most about it is that it provides a library of higher level resource types. So these have all of the AWS best practices built in, all of the same defaults that we like to use internally. So these are called constructs in the CDK. And these are some examples that the ECS team has been working on this year. So for example, the ECS cluster can automatically create a VPC for you for that cluster. The Fargate task definition has validation in it to ensure that you are providing all of the required attributes for Fargate. You can add a container image to that task definition, and if you're using an ECR image, it will actually add to your IAM role policy the permissions that ECS needs to pull that image. And then with the Fargate service, it again has all of the validation for what you need to provide for a Fargate service. And then even higher level above that is ECS patterns. So this is something that we recently reached GA state last month. And we've been working on this for a while, looking at all of the ECS services that customers are running and noticing that all of their infrastructure kind of looks the same. If they're running a load balance service, the load balancer is typically configured pretty much the same across all these services. And same for a network load balance service, same for a queue processing service, something that pulls work from SQS, or a scheduled task. So we notice that we can create some really sane default configuration to get you started creating all of this infrastructure. So as an example, this is just a few lines of TypeScript that I'm able to create an application load balanced Fargate service. So it's going to both create the cluster for me, it's going to create the VPC for me, it's going to create the task definition, the service, the CloudWatch logs group, the load balancer, the security groups, and it's going to hook all of it together so that when you deploy this, you just get a URL that you can hit immediately. So the other thing that's nice is that it can even build and push your Docker image and create the ECR repo for you. So it's really easy to get started out of the box creating ECS services. And then finally, when you synthesize this template, it's going to generate hundreds of lines of CloudFormation template that you didn't have to write. So with the CDK CLI, you can add this automation to your CI/CD process. You can use CDK synth in your build, and that will output a JSON CloudFormation template. And that JSON template can be promoted through your pipeline, like we saw in the Amazon pipeline example, and used with the, for example, CodePipeline CloudFormation action as is. You can also use the CDK deploy to synthesize and deploy directly your template with any other kind of automation like Jenkins. So CI/CD for AWS CDK code internally at Amazon looks really similar to what I showed you before. The repositories contain the application code and the CDK code in the same language or in a different language. The build stage will build and push the image, and then the CDK template that's synthesized will have that new image ID in it. And then what's promoted out of that build is, again, that JSON CloudFormation template, and that gets deployed in the test and production stage. So in order to do that, CodeBuild can be used to actually synthesize that template in the pipeline. So it's really easy to install and use the CDK CLI to synthesize my ECS service template. So then this is getting a bit meta. You can also describe your pipelines, your CDK pipelines in CDK. So here I have a deploy CDK pipeline class, and I'm adding a new pipeline resource to the CloudFormation stack it's going to create, and then adding a GitHub source action. And so below this, you would see the CodeBuild action and the ECS deploy action, and all of this can be used to generate a CloudFormation template that stands up your pipeline. And then because this is a familiar programming language, we get to use all the benefits of programming languages. We can actually stamp out multiple pipelines. So similar to how the infrastructure tends to look the same across all of our ECS service, and we can create patterns, we can also create patterns around our favorite pipeline configuration. Whether you use source, build, test, production, maybe you always have multiple production stages, maybe you will have a specific type of test that you always run in your pipeline. You can create that CDK pipeline class and then just stamp it out for each of your microservices. So I've talked about repeatable infrastructure changes and how important they are for CI/CD, for containers in the cloud and all of the infrastructure that goes around containers in the cloud, as well as making that a bit easier with CDK. And so now what we're going to have is Singwei is going to come on and do a live demo to show you these best practices in action. I'll go this way.
Great, thanks, Claire. So my name is Singwei Su, and I'm a software development engineer on the AWS Developer Experience team. And we're going to do a quick demo. So we're going to show an application that has 2 microservices that we can deploy independently using some of these best practices. So here we have our demo site, reinventtrivia.com. So you can test all of your reInvent knowledge. So for example, anyone know what world record was set at the 2017 reInvent Tatanka Challenge? Any veterans out there? Very good. It was the largest chicken wing eating contest with 214 people. That's like maybe this side of the room only. So we can do better. So this is a static site that's hosted in Amazon S3, and it's backed by an API that's running as a containerized service in AWS Fargate. So this is a public API, so if we go to that, the question endpoint, we can see an example of a response that's being returned by this Fargate service. Here, this is all of the question data in JSON. The code for this application is shared across 2 different repositories, one for my front end and one for my back end. And these would be owned by different engineering teams working within the same org in my startup here, so many H's, LLC. So ideally, since these code bases need to talk to each other, it'd be great if they could share similar infrastructure in each of their environments. So ideally, I would have a subdomain, in this case, test.reinventtrivia.com, that would talk to its respective service, the front end, which would talk to the test version of my Fargate API. So if I'm making some changes to my front end, here I'm in my test environment, I know that this is talking to a real back-end API, so I can see that things are working end-to-end. So in this case, I've made some changes to my background color, and I can see that everything is working. Okay. If we go to the ECS console, we can see that we have 2 Fargate services running, one in my test environment and one in my production environment. And each of these have 3 tasks running in each. Both of these services were created using ECS CDK patterns, which we'll talk about that in a little bit more detail in a minute. So with more instances of my services running in different environments, I want to make sure that nothing breaks when deploying to any of those stages, whether it's in staging or in production, and while still ensuring that I can have an automated and independent release process for each of my microservices. So we can do that by setting up pipelines for each of these in CodePipeline. So here is my front-end site. I have 3 stages: source, test, and production. In my source stage, it's hooked up to GitHub, so any push to that GitHub repository that we just saw will trigger this pipeline. I have a test environment and a prod environment that are backed by AWS CodeBuild, and in that build spec file, all this does is compile my static assets and deploys them to their respective S3 buckets. So I was happy with how my changes look just now in test, so I'm going to go ahead and enable this transition. And we'll see that go into production in a little bit. So now let's talk a little bit about safe deployments using blue-green deployments and automatic rollbacks when our code is a little bit more complicated and more things could go wrong. So here's the overall structure of how my backend, my API pipeline looks like. Again, I have my source stage that's hooked into GitHub, so git push will trigger this. My build stage, which is powered by CodeBuild, and this, again, will build my Docker image and push it to my ECR repository. My test and production stages are now using CodeDeploy, blue-green deployment strategies. So going back to my CodePipeline console, we can see that these are the stages, and I can run my test suite in any of these stages, including integration tests, monitor that all of my code that's been deployed is looking good and running smoothly before moving on to the next deployment stage. So if I'm making changes to that API code, I don't want to push a change that might affect another service that consumes it, in this case, the front-end site. Or even if I do push a bad change, I want to make sure that there are guardrails in place to make sure anything bad doesn't actually reach a stage where it might impact my customers. So we're going to talk about demo 2 of those triggers for the automatic rollbacks. The first is using Amazon CloudWatch alarms, and the second is using AWS CodeDeploy lifecycle hooks. These can be set up in any pre-production stage or during a production deployment itself, so that if one of the alarms goes off or if the validation in the hook fails, then it'll trigger an automatic rollback to the last good version of my application. So let's talk about the alarm trigger first. If I go to my CloudWatch metrics console, we can see that I have a few alarms set up, including a 500 error count on my target groups. I have a code change here that I've already pushed through into my pipeline that instead of returning a 404 when an endpoint is not found, I'm actually returning a 500 error. And we can see that that change is queued up in my test environment, changing my status to 500 here. And what that means is the deployment to this stage was successful. All of the integration tests pass. For all intents and purposes, it seems like this was a successful deployment. However, this was a bad code path that could actually be hit in production by actual customers. And there was no way to stop this from making it into my test environment. So to simulate that bad endpoint being hit, I have a script that will just make a curl request to a bad endpoint so that that 500 error will be returned. Okay. And I'm going to go ahead and enable this transition. So now that deployment should be underway. Now we're in the CodeDeploy console, and we can see this was the deployment that we just kicked off. So as Claire discussed, what this is doing with the blue-green deployment strategy is we're spinning up the new task set in the green target group. So right now, all of my traffic, 100% of my traffic is being served by my blue task set, my original task set. The new task set is being spun up. After that, the test traffic will be routed. And then we'll have the bake time that we discussed to see that everything is OK before terminating the original task set. Since we have that script that's running that's triggering, hopefully triggering that alarm with the 500 errors, we should expect that an automatic rollback will be triggered once CloudWatch reports that we are in alarm, and CodePipeline will automatically kick off deployment. So now let's talk about automatic rollbacks using CodeDeploy lifecycle hooks. So going back to our CodePipeline console, again, I have a change that's queued up in my build stage. And it says bad commit, but it's fine. I'm going to enable it to transition. And I can do this because I know that I have checks in place that will make sure that nothing bad will happen. And in this case, we set up a CodeDeploy lifecycle event hook. If we go into a previous successful deployment, this was a previous deployment to one of my pipeline stages, we can see that here are all of the deployment lifecycle events that I could have added a hook to, such as before and after install, before and after allowing test traffic, and so forth. And as mentioned before, we have a hook that's set up after allowing test traffic. And we can see the code for that here. The check is simply to see if I have the right number of categories for my data, so that if I don't have 4 categories, then I know that my data is not going to render correctly in that 4x4 matrix on the static site. Here's the bad code change. Some developer was having a bad day, and they just deleted all the data. So it's gone. They didn't have their coffee that day, so they deleted it and pushed it. And because we have that check in place for that lifecycle event, we do expect CodeDeploy, the validation, to fail, and that will trigger an automatic rollback in our pipeline. Okay. So now, while we're waiting for those deployments to finish, let's take a look at the CDK code that was used to set up both the pipelines and the Fargate service, so we can see some repeatable infrastructure changes at work. So here's the code for our ECS service. We have our Trivia backend stack here. And then we can set up some network infrastructure, including a VPC, an ECS cluster. We can configure our domain, use a TLS certificate. And then here is where we're using that ECS pattern that we talked about, which streamlines the process for instantiating your Fargate service, your load balancer, and all the other things that you would need to get a service up and running. Here is where I actually stamp out 2 copies of my load balanced Fargate service. So here I have my test service, and here I have my prod service. So if I wanted to make another copy of this service, it would be as simple as copying those 4 lines of code and then changing my domain to whatever new domain that I want to add in a new environment. Okay. So if I was to look at what that code, CDK code looks like when synthesized into CloudFormation, I can run CDK synth, and this is the CloudFormation. All the CloudFormation, still going. Okay. And that ends up being for only 64 lines of CDK code. That is 550 lines of CloudFormation that you don't have to write. So that's a lot of time saved. Similarly, for my CodePipeline, I have a custom construct defined here. It includes my CodePipeline pipeline, sets up my GitHub access token as a secret, so I'm not storing that secret out in the open in plain text. And then here I'm adding my source, and then also my build stage. And then for my 2 deploy stages, it's as simple as a single line of code. So if I wanted to add another CodeDeploy stage, all I'd have to do is copy that line and give it the name of that environment. Again, if we look at what that looks like in CloudFormation, it's all of this YAML that I wouldn't want to write myself. And that ends up being 844 lines of CloudFormation generated by only 134 lines of CDK code. So big savings. OK, so let's look at how our deployments are going. Okay. So our deployment to test has failed, which we expected. So if we look at the details, this will take us to our CodeDeploy console. And sure enough, we have a message that tells us our deployment failed because 1 or more of the lifecycle event validation functions failed. We can see here that the routing production traffic to the replacement task set was skipped. And in our lifecycle events, we can see that, in fact, at the event that we hooked into, it did fail. If we look back on the list view of deployments here, you can see that there's a revision location for that deployment and an identical revision location for another deployment that did succeed. And this was the rollback deployment that was automatically kicked off by CodeDeploy when the validation failed. So without any kind of manual intervention, this occurred and was successful. And we can see that traffic was routed 100% back to my original task set. And I didn't even have to do anything. Let's check on our alarms. We're still waiting on that. As a reminder, this is the deployment that's going to production that had the 500 error returned. It's still in progress. So we can wait for it, update our LinkedIn profiles, see that Claire Lagori has endorsed me for CI/CD. Cool. So now we are an alarm. As expected, this is the 500 alarm that was returned. If we go and look at our deployments, we can see that it's still reporting. So this should fail in a minute. We are an alarm, so that's good. We can play some more trivia while we're waiting. Oh, there we go. Okay, so we failed. So here we go. Linking to our execution details. as expected, one or more alarms have been activated during this deployment. This is the alarm that was activated during that bake period that we had built into the deployment. Going back to our list view, we can see that that deployment was stopped here with this revision ID, B1. So we can look up that next one for the rollback deployment. And fortunately, that one succeeded. It happened automatically and very quickly. Okay. So now we can go back to our production site, and we can see now that even though our backend was having kind of a bad day, those front-end changes that I deployed in the beginning made it through. We can see the new background color, and the front-end team wasn't impacted by the bad day that the backend team was having. So that concludes the demo. So to summarize, we talked about automated releases. We saw how we were able to independently release microservices using a fully automated CI/CD pipeline. We were able to demonstrate how we could execute safe deployments using blue-green deployment strategies with CodeDeploy, CodeDeploy lifecycle event hooks, and alarms that would trigger automatic rollbacks, ensuring that our application is always in a good state, with zero downtime, most importantly. And finally, we saw how we could use the CDK to make sure we had repeatable infrastructure. And so if we wanted to spin up another environment or another service, it ensures consistency so there are fewer surprises in production. Okay. So if you're interested in learning more, we have a few more breakout sessions, Dev 209, Introduction to DevOps in AWS, as well as SVS 336, CI/CD for serverless applications. And if you're interested in looking at this demo code, it's up on GitHub under AWS Samples, AWS reInvent 2019 trivia game. So thank you very much.